Hello, and welcome to another web learning episode where knowledge is shared. In this episode, I'll show how to use the STM Studio. The software that was developed by ST helps to debug and diagnose STM32 applications, while they are running by reading and displaying their variables in real time. The STM Studio interfaces with the STM32 MCU via the ST-Link development tools. This software can read the registers of the application without stopping the program. The STM Studio perfectly enhances traditional debugging tools to fine-tune applications. It is great when you need the debugging application which cannot be stopped, such as motor control, ADC, and other peripherals that you need to read the variables. Different graphic views are available to match the needs of debugging and diagnostics or demonstrate application behavior. So let's get started. First of all, we'll need to build an application. The application I'm going to use in order to see all the features is reading ADC. And while the ADC needs some kind of waveform, we'll use the dock, the internal dock of the STM32 in order to create a waveform. So from one pin we'll create a waveform, and from the other pin we'll read it. So let's start with a new project. Board selector. As always, I'm using the L053 demo board. We'll take ADC input 0 as our input. We'll use the dock as our output. And of course, we'll need to debug the device. Next, clock configuration. We'll put it at the highest speed. We'll let the STM32 cube to do it by itself. We'll go to configuration. And we'll change some of the settings. Now, if you haven't seen this tutorial on how to use the STM32 cube mix, I advise you to go back to video number 1 when I show exactly how to use this. So the resolution will be 12-bit. The clock will be divided by 2. Right alignment. Scan direction. We'll do it forward. Continuous conversion. We'll do enable. And we'll leave all the other settings the same. And we'll do sampling time 55.5. We'll click OK. We'll go to project, generate code. We'll call the project name STM Studio. In the code generator, we'll only copy necessary library files, set all 3 pins as analog input. And we'll generate the files. Open project. Open the main. And let's add some code in order for this to work. So we can see that the private variables have already been set for the ADC and for the dock. Now we need to use some user code. I'll run it quickly. Now the ST has accurate ADC, and in order to get all the benefits, there are 2 things that need to be done. One is a calibration, and the other one is the voltage difference depending on the VDD that you're using. This I'll show in a different video, but for the calibration it's very easy to use, and I'll show it here. So running the ADC calibration start, ADC single-ended, so I'm using only one ADC, and if there is anything wrong, it will jump to the error handler. It will be easier to debug this if there are any issues. Now some more settings in order to start the dock and start the ADC. Now this is how you set the duck and set the value of the duck. And we need to start the ADC. So after we started the ADC and we checked that there isn't any errors, we need to start the ADC, and at the same time we need to increment the duck. So fast forward this. So after reading the correct ADC into the ADC value, now we'll increment the duck. So in a nutshell, we do ADC pull-through conversion, so reading the ADC. We check if everything is fine with the ADC and it finished the reading. If it did, then we get the value and put it into the value ADC. And then we take the duck, we set it to a value. Then we increase the value in 1. And if the value reaches 4095, that's the 12-bit, we change the value to 0, and we do a short delay. Let's compile it, see that everything is fine. Reprogram the board. And let's open the STM Studio. So after opening the STM Studio, we need to import the values that we want to see. The two values that we're interested in are value DAC and value ADC. Those are the two values. One will be incremented to the DAC and one will be read from the DAC. So coming back to the STM Studio, the STM Studio is divided, the main screen is divided into a few sections. First of all, we have the valve viewer. This is the information, the visible information that we're retrieving from the board. We have the viewer settings where here we decide on what type of values we want to see from the registers. And this is the display variable settings. This is all the variables that we've imported and we'll see them. We have write variables. We can write them by ourselves and write the address or the display variables. So let's bring some variables of our project. Then we first of all import variables. Then we retrieve the executable file. The type of files are .elf, .out, and .axf. The Kyle generates AXF file, and in order to retrieve this, we go to the STM Studio project, MDK ARM, STM Studio, and here's the file. Here we can see all the variables that are in our project. What we're interested in is the value ADC and the value DAC. We're holding the control key. We highlight the two variables. We click import and we close. This is all the variables that we've imported, but they cannot be displayed yet. We need to drag them, again, control. We drag them into the list of variables. Now for those variables, we can either have it as a curve, as a bar graph, or as a table. I'll show them first of all as a table. And here we decide on which debugger we're using. Again, we're using the X-Nucleo, and it has a built-in ST-Link. So then we can have a look at the different acquisition settings. We can have maximum acquisition. Then we can do under sample data for graphical display or display all data. and then acquire all variables, acquire only variables used by viewers, or acquire only variables used by visible viewers. This will be the fastest way to show the information. Now we can log also the information in order to do some other stuff with those data. If we need to do some mathematical calculations and we need those variables, we can log them here. And we can do target communication and other information that you can explore. Clicking OK, and the only thing we need to do is start stop. And here immediately we see the values that's being read. And you can see the duck, and you can see the ADC following it. Now again, as I said before, we can have this view in different options. Now it's a table. Now we can change it as a bar graph. Now the bar graph is too big, then we right click on the window, outer range, right click, outer range, and then we can see everything. We can zoom in and out using the scroll of the mouse. We can change also into a curve. Now the curve is running. It's hard to see, I'll stop it. But you can see that there is the value of the duck and the value of the ADC, and you can see them following each other. I can zoom in with using the right click of the mouse. If I move it to the right, I zoom in to a certain section. If I click on the mouse on the right button and move it to the left, it zooms out. So again, we can zoom into a certain section, and right click and left, it zooms out. And play again, and you can see all the values. Now there are other things you can explore with this. Again, there are different snapshot mode or acquisition mode, and you can change it to different views. You can change the upper value. You can do a pointer value. You can point the viewer settings. There are so many things you can do with this, and it greatly helps when you're trying to debug your code. For a quick example, let me show you what happens. Let's take our code and move the A. Compile, download the code, reset the board, and click play. Now look what happens. This, for example, shows you what happens when we're stopping the delay of the board, and this is happening because in the code, I'm not waiting for the duck to settle like I'm doing with the ADC, that I'm waiting for it to finish the settings. And because it's working really, really quickly, the duck doesn't have time to stabilize. We can actually see that the ADC is following the duck. You see the ADC is following the duck because the ADC is much quicker than the duck. But the duck doesn't have time to settle. If we put back the delay, compile, download, reset the board, and it's working again. Let me zoom out. And it's working again fine. Again, in order for it to work without the delay, all you need to do is put the state of the duck to settle down, and then you be sure that the actual value is being output. I hope you enjoyed this video. click on the subscribe button to get more notifications when I upload new videos. Thank you.